Hello friends, welcome to my channel. Myself Mrs. Mohana Karangale from Arihant College of Arts, Commerce and Science, Camp Pune. Today's topic is Davison-Germer experiment. In 1927, Davison and Germer performed an experiment on electron diffraction by the help of single crystal of nickel and confirmed the wave-like nature of electron. The experimental arrangement for the electron diffraction is as shown in figure. Now come to the construction and working of this experiment. It consists of an electron gun, nickel crystal and electron detector. Electron gun has tungsten filament coated with barium oxide for high emission efficiency. The filament work as a thermionic cathode. The electrons are accelerated by cylindrical anode kept at a fixed known high positive voltage V. The anode imparts the desired velocity to electrons. The electrons emerge out of anode aperture as fine beam. This beam is incident on the nickel crystal. Now the electron beam gets scattered in all directions. The intensity of scattered beam can be measured by electron detector, which can be moved on a circular scale. The detector is connected to a sensitive galvanometer whose detection is directly proportional to the intensity of the electrons received by the detector. The whole experimental setup is enclosed in evacuated chamber. This is the diagram of electrons reflected from crystal planes. The angle phi between the incident and the scattered beams called as scattering angle. In this experiment, the maximum number of scattered electrons was detected for phi is equals to 50 degree and the electrons accelerated through a potential difference of V is 54 volts. Thus, a beam of electrons reflected from a set of parallel atomic planes of a crystal would produce a diffraction pattern provided the path difference between the neighboring atomic planes equal to an integral number of wavelengths. A condition for constructive superposition is lambda is equal to 2d sine theta, where d is the spacing between the atomic planes, lambda is the wavelength of the associated wave, and theta is the glancing angle. It is one of the important term. For the scattering angle, phi is equals to 50 degree and the glancing angle is theta is equals to 65 degree. The spacing between the atomic planes for the nickel is small d is equals to 0.91 angstrom unit. If we put these values, then we get lambda is equals to 2 into 0.91 into 10 raised to the power minus 10 into sine of 65. So we get lambda is equals to 1.65 angstrom unit. This is the wavelength of electron wave found experimentally. But by using de Broglie's relation, the wavelength of the electron at accelerated voltage 54 volts is given by lambda is equals to 12.27 upon under root of V angstrom unit, it is equals to 12.27 by under root of 54. So we get 1.67 angstrom unit. This is the experimental and excellent agreement between the experimental and theoretical value of the wavelength of electrons. The significance of this experiment is that the Davison and Germer experiment is directly indicated the wave nature of material